have express area in terms of x, and here we have a 22 meter long wire. And on this wire, we want to cut it into two pieces. And so when we do that, we want to make a square. And the square has side x to it. So this length right here is going to be 4x because there's 4 sides. So that's going to be x and x and x and x. That's 4x. Okay? So this wire is going to make like a little box there. And then the other wire, we're going to make a circle from that. Well, if this is 22 meters and we know this is 4x, then the rest of it must be 22 minus 4x. So this part here is 22 minus this part here is 22 minus 4x. Okay, so from here we're going to have to, let's go ahead and reconstruct that. And so from there, we're okay, so here's our wire, and we know that's 22 meters from top to bottom. And we know there's one part that we're going to cut that, and so we're going to make a box, and we know that box is going to have side x to it, and we're going to make a circle. Well, if this is 4x, then this must be 22 minus 4x. Okay, so from here, we want, so the idea here is that express our total area A enclosed by the pieces of wire as a function of the length x of the side of the square. So here, the side of the square, that's going to, be our independent variable, or our, and so we're looking at area in terms of x. Okay, so basically what we've got here is we want to find area in terms of x, but we've got two pieces here. So we're going to have to find the area of the square, we'll call that A of s, and the area of the circle. Well, the area of the square, that's area of the box, right? That's just length times width. Well, if the length is x and the width is x, then that area of the square is x squared. So we've already got the area of the square down. So we have to find the area. So this we already know. This is A of x equals to x squared. Okay, so we're all set for the area of the square. But now we need to find the area of the circle. Well, when we take this wire and bend it around, that's actually circumference, because we're looking at just that outer edge. And we know the circumference of a circle is 2 pi r. And we'll call that C1. And so from there, this circumference of the wire, we'll call that C2, we know that's 22 minus 4x. Okay, because we take that wire and we bend it around like a circle, that's our circumference. So we know that circumference of one circle, circumference of our general equation is equivalent to circumference of our wire. So we're going to make this 2 pi r is equal to 22 minus 4x. And the reason is because we don't want a function for r, we want a function for x. But area of a circle, the area of a circle is pi r squared. But we don't want r, we want x. So we have to take, what we want to do here is we want to get x into this equation, not r. So that's why we have to put the 2 pi r equals to 22 minus 4x so that we can solve for r and then substitute it in here. So first thing we're going to do is we're going to make life a little bit easier for ourselves, and we're going to, everything is a multiple of 2, so we're going to divide everything by 2. Divide by 2, divide by 2, divide by 2. And we get pi r equals to 11 minus 2x. And then we're going to go ahead and divide everything by pi. Divide by pi, divide by, and we're going to put the whole thing in pi, and I'll show you why we're going to put it all in one. Usually I tell you to split it, but this time we're going to put it all in one for right now. Alright, now from here, so that gives us r. That means that now we have r equals to 11 minus 2x over pi. Okay, now what we can do is we can take this area equation, because that's what we want. We want area of the circle. So now we can take this area equation and we can substitute. It's like we're cutting the r out, and we're going to put this equation in there for r. So this will be pi, and then where the r was, we put parentheses. Squared, and now we're going to put the 11 minus 2x in there over pi. And so the square is squaring everything, including the pi. And so from that, we're going to get, basically what we have here is 11 minus 2x make this more like a more curved parentheses, there we go, times 11 minus 2x, and we're going to FOIL that over, well, we square that, and so we still have this pi outside here, that's this, but now we have pi squared down here, because that's going to be this squared, numerator squared, and denominator squared. Well, pi can cancel into pi squared, and that just leaves us with pi. And now we distribute, we FOIL, and we get (11 times 11), that's 121, and then we get a minus 11 times 2, that's 22, minus 22x, minus 22x, that's a minus 44x. And then a minus 2 times minus 2, that's going to be a plus 4x squared over pi. And that's Okay, so that's the area equation for our circle. So now we can complete that. Now we can put that into our a of x equation. So that'll be a of x is equal to x squared plus, and then this goes in here for the a of c, this part here. 121 minus 4x plus 4x squared. Kind of hard to see that. Plus 4x squared. And that's over pi. And so from there, we have our function. This is our answer here. That's our function equation. Okay, now also, let's see what else it asks us to do. Alright, from here, they want to know what is the domain. So basically, what you're doing with that is we want to know domain. So that'd be part B. Not the easiest thing to try to write in the art program. You take in your 22 minus 4x and you set it equal to 0, and actually in this case you're going to, we'll go ahead and we'll just make it greater than 0, because we're going to go ahead and put that in set notation. So we apply minus 22 and divide by negative 4. Well, that's going to switch that inequality sign and make it x is less than. And so that'll be a positive 11 over 2. And so our domain is going to be, here's curly bracket x, and then we have here x is less than 11 over 2. So in interval notation, that would be negative infinity, and then 11 over 2, and that's open. Alright, so that's our domain, and we want to graph that. And what values of x is the smallest? Well, when we do that, we're going to get, you go ahead and you apply it in your calculator and you work it from there. So let's try that. So let's see now, we're going to put in here x squared plus, and then we're going to put in parentheses, and we're going to put in 121 minus 4x plus 4x squared. Now you could have put 4x squared minus 4x plus 121. You could have done that too. Close parentheses, divided by, since there's only a single term there, you don't have to put parentheses for the denominator. And so that would be just divide by pi. And let's see now, if we went to zoom And let's see if zoom fit will work for us. Okay, we get a parabola. I'm going to see if we can go to Z standard, see what happens there. 6. Okay, nothing, you can't see it. So if we go back to Z fit, I'm curious to see how far down that went. Now if we go back to Z fit and then look at your minimum, your window, Y minimum is 38. So I'm going to go a little bit below that and make that 30. Go back to the graph because I like to see a little bit of space down there. Alright, now we're going to go to second in calc and we're going to go to 3. And it wants left bound, so we're going to cursor to the left of that, hit enter. Right bound, cursor to the right of that, hit enter. Again, and I get 0.2800495 for X, and for Y I get 38.337. So we can say that on the graph, it looks something, for the window that we have, it looks something like this. This point comes out to be, we're going to say 0.28. And 38.34. Okay, and so that would be our answer there.